Say you've got website logs in one S3 bucket, customer profiles stored in Salesforce, and sales data tucked away in a MySQL database. That raw data isn't ready for analysis right away. You need to clean it, structure it, and send it somewhere useful, maybe to Redshift, S3, or a data lake. AWS Glue ETL jobs are built to handle exactly that. Hi, I'm Professor Reza's AI avatar. And in this video, we'll go over what an AWS Glue ETL job really is, how partitions fit into the picture, and what kind of transformations you can apply. We'll also break down what workers are, how they affect performance, and the choices you have. By the end of this video, you'll have a clear understanding of how Glue ETL jobs work, what they're made of, and how to start thinking about setting one up. Alright, before we jump into the details of Glue ETL jobs, let's quickly talk about partitions in AWS. Partitioning is one of the best ways to increase performance and cut down on costs. Partitioning is basically dividing the data into smaller chunks based on specific values, like dates, so we don't have to search through everything to find what we're looking for. Its main benefit is that we end up processing a lot less data, so we're incurring a lot less compute costs. It also makes everything more organized, and it increases query performance. This might not be very relevant for small datasets, but if the data you're working with is extremely large, this does matter a lot. Partitioning is usually based on things like dates, geographic info like country or region, or categories like product type or department. Basically, whatever makes sense for your data. In S3, it's generally implemented through folder structures. Each level of the folder structure represents a partition key. And AWS Glue recognizes this automatically, so you don't have to do anything about that. When managing partitions, we can either manually add or update partitions in the data catalog, or we can create ETL jobs to write data in a partition format, or we can just have the crawlers automatically detect and update partitions. Now that we know how partitions work, it's time to talk about the most important thing in AWS Glue, the ETL jobs. This is where the actual transformation of your data happens. An ETL job in AWS Glue is basically the logic to extract data from different sources, transform it, and load it into whatever destination we need to load it into. These jobs are written in either PySpark or Scala. PySpark is more accessible in general and it has better documentation, but it tends to run a little slower than Scala. But overall, PySpark can do everything Scala can, which makes it the easier choice to work with. And you're not sacrificing much in terms of performance. With ETL jobs, we can perform all sorts of transformations. Convert formats like CSV to JSON or the other way around, modify schemas by adding, removing, or renaming columns, filter or clean up messy data, join or aggregate datasets, and run whatever calculations we need. All of that falls under transformation logic, and how we set it up depends on the kind of resource allocation we want. In the setup, we need to configure the type of worker we're going to have standard G1X or G2X. We will talk about this in a minute. The number of workers. How many parallel processors do we want to use at the same time? Maximum concurrency. How many instances of the job can run simultaneously? And job timeout, which is the maximum amount of time the job is allowed to run before it gets terminated. This prevents it from running endlessly and costing us a ton of money. A typical job execution flow starts with the ETL job creating a Spark environment. Then, it reads data from the sources using the metadata stored in the Glue data catalog. Again, the data itself is not stored in the data catalog, we just look at the data catalog to see where the information is. For example, in our case, it's going to be stored in S3, but as we mentioned before, it can be stored in external sources too. Once we make sure we have access to our data, we can do whatever transformation we want to do according to our script, and then we write the results to our destination, and then the job completes, and we give away the resources. And the last thing you need to know about ETL jobs is workers. Workers in AWS Glue are the compute resources that run your ETL job. When setting up a job, you choose the type of worker based on how much memory and CPU your transformations need. The standard worker is the default option. It's good for general-purpose tasks and is the most cost-effective for typical workloads. We also have G1X and G2X workers. G1X workers have fewer resources than standard, but are optimized for memory-intensive jobs. They work well for tasks like joining large datasets and offer better performance and cost efficiency in those cases. G2X workers offer even more memory and CPU, and they're built for heavy memory processing or machine learning tasks. They're more powerful and also more efficient when you need serious compute power. So that's the big picture of what AWS Glue ETL jobs are all about. They let you extract, transform, and load data at scale with flexibility and control. You've seen how they work, what kind of logic you can write, and how workers and partitions tie into the whole process. In the next video, we're going to get into how to actually set up ETL jobs in the AWS Glue console, step by step. See you in the next one.